Climate change is not only warming the lower part of the atmosphere where we live, it's also changing the basic state of the atmosphere 10 kilometres high above our heads where planes fly. And in particular, climate change is strengthening the atmospheric jet stream. This is making the atmosphere more susceptible to the instability that causes turbulence to form.
I believe you concentrate mostly on the North Atlantic corridor. Would that be specifically where the turbulence could increase, or would it be globally?
Well, we focused on the transatlantic flight corridor because it's an important flight corridor. There are 600 planes crossing the North Atlantic Ocean every day, 300 westbound from Europe to North America and 300 eastbound from North America back to Europe. But I would like to extend this study in future to look at other parts of airspace. Wherever the strength of the winds at a height of 10 kilometres gets stronger, that would tend to increase the particular instability that causes turbulence to form. And so wherever you see a stronger jet stream, and the jet stream is not confined to the North Atlantic Ocean but moves around the entire Northern Hemisphere, you would expect to see an increase in turbulence wherever it gets stronger. But for now, we've just focused on the North Atlantic, and we would like to leave the other parts of the world for future work.
Now, this is the first study of its kind, I believe. How did you go about detecting air turbulence?
So this is a computer modelling study where we've taken one of the world's best climate models, and it's been run on one of the world's fastest supercomputers. And we've done two simulations, one corresponding to the pre-industrial atmosphere when CO2 was relatively low, and then another, which we've compared it to, where the CO2 was double its pre-industrial value. And CO2 in the Earth's atmosphere is expected to double by around the middle of this century. And what we've done is we've calculated 21 different measures of estimating turbulence in those two simulations, and found that the average strength of clear air turbulence will increase by between 10% and 40%, but that the amount of airspace containing significant turbulence is likely to double by the middle of this century. So the range of increases is anywhere from 40% to 170%, but the most common outcome was a rise of 100%, which means a doubling of the amount of airspace containing significant turbulence.
Could that potentially affect flight routes in future?
It's plausible that if the atmosphere contains more turbulence and flights want to avoid flying straight into it and around it, flight routes will have to become more convoluted than they are today. And that could, of course, increase journey times, increase fuel consumption, push up prices to airlines and potentially also to passengers.
What do you think needs to be done to tackle this problem?
I think the only ray of light I can see for avoiding the fasten your seatbelt sign being switched on twice as commonly as it is today is if scientists get better at predicting in advance where and when turbulence will strike. We've focused on clear air turbulence, which is invisible. Pilots can't see it from the plane. The electronics on the plane cannot see it. It comes very unexpectedly when it happens, typically at cruising levels when the seatbelts are not on and passengers are wandering around the plane and flight conditions appear to be smooth. Suddenly you can hit this turbulence which comes out of the blue. And so the ray of hope, I think, is if we can get better at predicting those patches of turbulence a few hours in advance or perhaps a day in advance, and then the pilot can be advised of the situation and can plan the flight route accordingly to avoid the turbulence instead of flying straight into it.
So I know we briefly touched on this earlier, but how dangerous could this potentially be?
I don't think anyone should be put off flying because of this. Turbulence will remain a rare phenomenon. We're talking about an increase from 1% of airspace containing turbulence to 2% of airspace, which still means that 98% of airspace is smooth. So I don't think anyone should stop flying because of this, but we can expect flights to become less comfortable, and that is something that passengers may notice in the coming decades.